This is a simple demonstration of the concepts you learned in my tutorial. I also added the time slap effect especially for you, so check it out in the video. I didn't fix the character movement animation while playing the anim montage because I was focused only on making the magic spell attack. Create basic folders for better organization in UE5. Now let's make the magic spell projectile actor blueprint and drop in some key components. For this projectile setup in UE5, we need a few essential components: a sphere collision, an optional static mesh, and a Niagara system or particle system to handle the visual effects. In this magic spell projectile, the collision presets are very important because they determine what the spell can hit, such as walls or enemies. We also add logic for what happens when it hits a wall and what happens when it hits an enemy. So watch this part carefully and don't skip it.
I'm here to tell you right now, we don't care.
Let me tell you something.
We don't care.
And next, adding the component's value. Before attaching the sphere collision to the default scene route, you can't modify anything inside the sphere collision, but this step is very important because it enables hit events. After that, I attached both components as children of the sphere collision, and then attached the sphere collision to the default scene route in the Components tab. Adding a static mesh component is optional. I chose to use a static mesh for my magic spell to give it a ball-like appearance, so I added it. Create a new material and assign it to the magic ball mesh component. Download a Niagara system from Fab. It's free to use. I've already used one, so feel free to choose whichever you like. I also assigned the Niagara system to the component in the blueprint. I used the Galaxy Arrow Niagara system, but I didn't want the arrow element. I opened the Niagara system and removed the arrow system node from the graph. I downloaded the Standing Idle 4 animation from Mixamo and used it. Now I want a spell throwing animation, so I trimmed the original to fit. You can choose whichever animation you like, from Mixamo, Fab, or your own custom animation. I also imported the animation FBX files into the mesh folder and retargeted the animation to UE5 Manny. This step is optional. If you're not satisfied with the default animation play rate, you can increase it to 1.6 by adjusting the play rate value in the animation section. You can also create an animation montage for this animation. Next, import the audio files for the magic spell. This may include charge-up sounds, spellcast cues, and impact effects depending on your design. Create an input action for casting the magic projectile, or simply buying the left mouse button key if you prefer a quick setup. Add a play montage node to trigger the casting animation. You can place the magic projectile spawn logic inside an anim notify within the montage for precise timing.
Add 3 notify tracks to the animation montage so you can organize different events, such as spawning the projectile, playing audio cues, and triggering the effects. Add a timed Niagara system notify to the montage. In my case, the Niagara effect starts when the character throws the ball or channels energy in the hand, and it stops at the end of the animation. If you're using a different animation, place the end notify wherever the effect should stop. In Unreal Engine 5.6, the third-person template already includes a default hand socket. I used this socket as the attach point for the timed Niagara notify and assigned the Niagara system I wanted to use. Add a play sound notify to the montage at the point where you want the audio to play.
Insert a new notify in the animation montage at the moment the character should fire the projectile, ensuring the release timing matches the animation.
Add a new custom event called, and inside it, implement the logic required to spawn and initialize the actor. For the spawn transform, I'm using the character's hand socket for the starting location and the camera's rotation for the projectile direction. You can also use a weapon socket if your character is holding a weapon. I've made a short video covering that setup as well. Create a new scene component in the Components tab, parent it under the third-person character mesh, and attach it to the hand R grip socket. Use this scene component as the designated spawn location for the magic projectile event. In the tutorial example, the event is called in the animation blueprint using a cast to the character blueprint. However, for production-level optimization, replace the cast with an animation blueprint interface to communicate the event efficiently. The system works as intended, but the character was snapping toward the animation's starting rotation. I enabled Use Controller Rotation Ya to maintain the controller's facing direction, and additionally adjusted the camera position to achieve a cleaner presentation during the ability animation. It's working fine. Let's move on to the next step. Set up a dummy actor to test the projectile. You can use your enemy AI if you prefer, but I'm using a basic dummy for demonstration. This step is essential for confirming that the projectile actor behaves correctly, so don't skip it.
What? Bro, what are you talking about, man?
Please watch the entire video without skipping. The time-lapse portions are included only to emphasize crucial steps in this tutorial.
Stop it. Get some help.
If you watch the full video without skipping, thank you so much for sticking around. And thanks for watching. Pay close attention here, because we need to configure the projectile's collision preset to ensure it properly triggers hit events. Add the event hit node. If you don't receive hit events, make sure Simulation Generates Hit Events is enabled in the collision section of the Sphere Collision Details panel, or rewatch the step to see what you missed. I used an actor tag node to identify what the projectile hits. The projectile's collision was set to ignore pawn, which caused it to ignore both the player and the enemy. I needed the projectile to ignore only the player but hit the enemy. To solve this, I set the enemy's capsule component collision preset to block all, allowing the projectile to generate hit events on enemies. Add sound effects at the hit location and spawn either a particle or Niagara system at the impact point. Use spawn emitter at location for particle systems and spawn system at location for Niagara systems.
After playing the effects, destroy the projectile using Destroy Actor. To avoid unwanted errors, use an isValid self-check before calling Destroy Actor.
I realized I made a mistake in this step. Set the class on the getActorOfClass node before promoting the return value to a variable. This allows Unreal to assign the correct, specific data type. If you promote the variable first and choose the actor class afterward, the variable becomes a generic actor reference, which cannot access the specific actor's properties or functions.
First, check that the Ragdoll works correctly on the dummy when it is hit by the magic projectile. After confirming that the Ragdoll reaction is working, add the Destroy Actor node. Now that it's working correctly, we can add the Destroy Actor node. Since this actor also has a condition check, make sure to add the false branch logic as well. Great, everything is working properly. Thanks for watching. If you'd like to see the character launch feature, stay tuned until the end of the video. With the default launch character node, you can enter a launch vector manually, and that works to some extent. But there's a problem: if the player hits the enemy from the front or the side, the enemy still moves in the same fixed direction based only on your XYZ values. That feels unrealistic. So I came up with a better solution for this. Watch this next part carefully.
My mistake. I forgot to add the launch character logic to the Projectile SIPs hit event.
Insert a short delay node after the launch character call and before triggering the Ragdoll event, so the launch velocity is applied first and not blocked by physics simulation. I will demonstrate what happens when there is no delay node. I set the launch character Z value too high, so I changed it, and you can adjust the value if you want. Adjust the normalize node output and multiply factor to balance the strength of the launch. It didn't work because I reversed the subtraction when calculating the actor location. That mistake flipped the direction, so the launch didn't behave correctly. Now the issue is fixed, and everything works correctly. Also add the sound and explosion particle or Niagara system when the magic doesn't hit anything. Connect this before the delay node, and then into destroy actor. I realized I forgot to add the explosion sound effect, so I included it in the place sound at location node. And finally, I created the enemy spawn system. It's very simple. Inside this actor blueprint, I use an event tick with a 3 to 5 second delay to spawn the enemy. Make sure that in the enemy blueprint, you select the root self component. Then in the details panel, search for pawn. Set auto possess AI to placed in world or spawned. If you don't do this, any AI move to or other AI logic will not work. I found one issue. The dummy actor doesn't get destroyed before the next one spawns. This causes two of the same blueprint to exist at the same time, and the Ragdoll and launch events won't work correctly. You need to destroy the first dummy. Add a delay after the Ragdoll in the enemy blueprint. After 5 seconds, destroy the actor automatically. This fixes the issue. If you know a better method, feel free to share. We learn together. Thanks for watching. Don't forget to like and subscribe, and let me know in the comments which video mechanics you'd like to see next.